Okay, picture this for a second. You're maybe 15,000 feet down.
Right.
Crushing pressure, searing heat. You're running pipe, super expensive stuff, thousands per foot.
Yeah, the stakes are high down there.
Incredibly high. And the whole thing, all that infrastructure, really hinges on one tiny point, right? The threaded connection.
That's the weak link, potentially.
And the lubricant, the thread compound you picked. Now, just imagine one single casing thread seizes. Or maybe a corroded connection, it just doesn't hold torque.
Disaster.
Boom, exactly. Production targets, gone, turned to dust. And suddenly you're facing, well, potentially millions in downtime, not even mentioning the stack of corrective action reports piling up.
That small choice suddenly becomes enormous.
Right. So, okay, let's unpack this a bit.
Mm.
Today we're doing a deep dive into really the frontline defense for these big industrial assets. High-performance thread compounds.
Critical stuff.
Yeah, and our sources are really looking at how these materials have evolved. We're focusing specifically on BESTOLIFE 2000 series and also, importantly, the wholesale supply side. How do you actually get this stuff reliably?
The logistics are key.
Totally. So our mission here is to figure out how the industry is moving past that older chemistry to fight both downtime and those regulatory risks at the same time.
And what's really fascinating, I think, and you've set it up perfectly for you listening, it's this core conflict. It's the inertia, the old habits, especially in specialized fields.
Yeah, that resistance to change.
Exactly. Versus the absolute non-negotiable need for predictable performance today. I mean, we're operating in places we couldn't even reach before. HPHT, deep offshore, the Arctic.
Extreme environments.
Totally extreme. And those, let's say, cheaper, older pipe dopes that maybe worked okay 30 years ago, they're just a massive liability now, a quantifiable risk.
It is amazing, though, isn't it? That resistance around what seems like a simple consumable. People just stick with what they know.
It's human nature, I suppose. Comfort zone.
So let's zero in on that liability.
Yeah.
What are the actual operational costs of sticking with, as you put it, yesterday's gunk? It's got to be more than just, taking a bit longer to make up a connection.
Oh, it's way beyond that. You're looking at a double threat, really. Mechanical failure and regulatory failure.
Okay.
So on the mechanical side, those traditional compounds, particularly the ones heavy with lead or lots of zinc, they just don't have the thermal stability or the film strength you need for modern wells.
Right.
Just think about what's happening in an HPHT well, that high temperature. It basically cooks the lubricant, the film migrates, it degrades, sometimes completely.
Leaving the threads bare,
Yeah.
essentially.
Then you add the intense loading. Often it's cyclical loading too, right? The pipe stretching, getting torqued again and again. That literally shears the lubricant film. And that leads straight to galling metal-on-metal contact, unpredictable stress. So then what happens? Busted threads. You got to intervene, trip pipe out of the hole, or worse, you leave damaged connections down there.
That sounds like a seven-figure problem waiting to happen instantly.
Easily 7 figures. So the material fails because the environment, chemically or physically, just breaks down the lubricant, meaning the connection is basically unprotected right when it needs protection the most.
Precisely. And that connects to the second big liability, compliance risk.
Okay, the regulatory side.
Yeah. If you're still using those lead compounds, or the ones heavy with zinc, you are instantly making your operations more complex. Hazardous material handling rules kick in.
Right. OSHA, EPA.
Yeah.
They're watching.
They are definitely watching. And every single ounce of that old stuff needs special storage, specific handling procedures, and critically expensive documented cleanups and disposal.
It's not just buying a bucket of dope anymore.
Not at all. You're buying an audit risk. You're setting yourself up for potential environmental liabilities that could stretch years down the road. So by holding on to those outdated materials, companies are essentially gambling with their environmental reputation just to maybe save a few bucks on the initial purchase.
Which seems incredibly short-sighted when you put it like that.
It really does. So when we talk about making the switch, moving to something like the BESTOLIFE 2000 series, we're not just talking about a small product upgrade. It's more like buying an operational insurance policy.
That's a good way to put it.
Yeah, insurance against mechanical seizure, against that catastrophic corrosion, and against those really expensive compliance headaches.
Protecting the profit margin, essentially.
Exactly. But okay, this shift, it brings up a really crucial question. If getting rid of the lead and the heavy zinc is so important for compliance, How do the modern engineers make sure that the new compound, the compliant one, actually gives better protection, better than the old stuff against galling and seizure?
That's the million-dollar question, isn't it? The
Yeah.
core challenge.
Yeah, the compound has to like thumb its nose at searing heat, crushing pressure, corrosive brines, all of it.
It's a massive chemical engineering challenge, no
Yeah.
doubt. The basic goal of any anti-seize is stopping the threads from welding together under extreme pressure.
Right, preventing that metal-to-metal fusion.
Precisely. And doing that without lead or zinc, which, traditionally people relied on them for their sort of bulk and sacrificial properties. Well, it means synthesizing advanced nonmetallic solids and special thickeners, things that maintain that film strength and lubricity across this incredibly wide range of conditions.
Okay, so advanced chemistry.
Very advanced. The standard BESTOLIFE 2000, for instance, it achieves this with what they call a zero heavy metal headaches formulation. It's totally lead-free and zinc-free.
Gotcha.
And that's not just ticking a regulatory box. It really simplifies handling on the rig floor. It cuts cleanup costs practically to zero, and it instantly improves the whole material safety data sheet profile for the operation.
So the clean sheet starts with compliance, makes sense. But the performance has to be there too.
Oh, absolutely. Performance is paramount. The stability of this compound is key. It's engineered specifically to stay put. Whether it's facing those HPHT conditions deep downhole or, sitting on a freezing rig floor 1 minute and then baking in the sun the next.
That's a huge temperature swing.
Massive. It has to resist washout from drilling fluids, stay stable under that intense cyclic loading without migrating away or breaking down.
Okay.
And that superior stability, that means you get reliable torque control, consistent thread makeup every single time you run pipe.
Which sounds incredibly versatile. Are we talking about like one product handling almost everything? Is it really that universal?
For most standard operations, yeah. It's
Okay.
designed for universal use casing, tubing, line pipe, and really critically, it's compatible with all the API connections and also the premium connections you see more and more. No interference, no compatibility surprises.
That alone must simplify inventory massively.
Hugely. Just think, one product for most of your needs. And the end result is what the operations manager truly cares about, right? Reliable protection against galling and seizure, plus exceptional corrosion resistance.
Which means smooth makeup, easy breakout.
Exactly. Maximizing uptime, keeping the crew efficient, less hassle, basically.
Okay, that makes perfect sense for, let's call them standard operations.
Oh.
But here's where, for me, it gets really interesting because not every environment is standard.
Sure.
We know the constraints of the standard compound. It works across API, handles diverse temps. But what about those specialized situations, like environments that demand absolutely zero metallic debris, or where you've got incredibly aggressive chemical exposure?
Right. That's where you move beyond the standard workhorse and into the really specialized tools, like BESTOLIFE 2000M. That's the non-metallic version.
Non-metallic, okay.
This is the one you reach for when the job demands, let's say, zero compromise on chemical exposure, or where any metallic content at all could actually harm the process or the connection itself.
Okay, hang on. Give me an example. Why would metal particles be unacceptable? Kind of seems counterintuitive, right? Removing metal from something that's supposed to protect metal.
Yeah, it did seem odd at first glance. But it's crucial when you're dealing with hyper-aggressive environments. Think particularly about sour service high H2S, hydrogen sulfide.
Okay, sour gas wells. Nasty stuff.
Extremely nasty. In those conditions, metals, even tiny trace amounts in the compound, can actually act as catalysts. They can speed up chemical reactions. Things like sulfide stress cracking in the pipe body itself.
So the compound itself could contribute to pipe failure?
Potentially, yes. So the non-metallic formulation, because it achieves this unbeatable chemical inertness, it eliminates that specific risk entirely.
Makes sense.
So the NM version, with its specific specs, it holds up to 500 degrees Fahrenheit total chemical stability. It's the necessary upgrade for getting maximum performance in those really harsh settings. You ensure the connection's integrity without introducing a new chemical weak point.
Got it. So NM handles the intense heat and the chemical attack. Now, let's flip the thermometer way down. Let's talk Arctic grade.
Right. The other extreme.
Yeah, if you're pounding pipe in, say, the Canadian muskeg in winter or up on the North Slope, a standard compound that thickens up or freezes up, like the source material says,
Right.
that's worse than useless, right?
Oh, absolutely. In the cold, the flow properties become the single most critical factor. A standard lubricant, perfectly fine at, say, 70 degrees Fahrenheit, might turn into stiff putty at -20.
And spread it properly.
Exactly. If it stiffens up, the crew physically can't get it to spread evenly onto the threads. You get inconsistent application.
Which means inconsistent torque.
Precisely. Inconsistent torquing leads straight to a compromised connection, one that might look okay on the surface, but could fail prematurely once it gets downhole and sees operating temperatures and pressures.
A hidden failure waiting to happen.
Definitely. So the BESTOLIFE 2000 Arctic grade, the AG version, it's chemically engineered specifically to beat that problem. The formulation ensures it, well, the source says it, slathers on like butter, even when the temperature is totally bottomed out.
Slathers on like butter. I like that.
It paints a picture, doesn't it? But that smooth, consistent application, even in blizzard conditions, is critical. It ensures you get proper thread engagement and protection. It takes the guesswork out of cold weather operations.
Okay, this all points to some really impressive deep engineering. But let's step back for a second, maybe into the procurement office or the boardroom. Moving an entire operation over to a premium, maybe specialized compound like this. It must come with a pretty substantial initial cost increase compared to those old, cheaper, heavy metal dopes, right?
That's a fantastic question, a really crucial one.
So how do companies justify that upfront cost? Strategically.
It hinges entirely on risk mitigation and looking at the total cost of ownership, not just the price tag on the bucket.
Okay, total cost. Makes sense.
Think about it. If a barrel of cheap dope saves you maybe $1,000 up front, but it contributes to just one connection failure that leads to, say, 2 weeks of lost rig time.
Which could be millions.
Easily $5 to $10 million, depending on the rig. The math becomes incredibly obvious very quickly. That premium compound isn't just a cost, it's an investment in predictable uptime.
Right.
Plus, it eliminates all those hidden liabilities we talked about, the cleanup, the special disposal, the potential regulatory fines.
Yeah.
So the overall project cost actually ends up being significantly lower and definitely more predictable.
Okay, that calculus makes sense. And it leads us perfectly into the next piece. Supply chain resilience.
Ah, yes, getting the stuff.
Yeah, because even the best engineered compound in the world is totally worthless if it's stuck on back order when the rig crew needs it now. So how does that product reliability get matched by supply reliability?
Okay, so now we pivot a bit. From the chemistry of the compound itself to the economics and logistics of procurement. For these kinds of specialty chemicals, strategic sourcing is absolutely key. The source material we looked at actually details using a specialized industrial supplier, something like peenergy.com. And this really shows how smart procurement managers are actively mitigating supply risk.
Okay, so using a specialist supplier.
Yes, because when you're running a multi-million-dollar operation, you simply cannot rely on a general distributor who might prioritize, I don't know, retail paint over critical well site chemicals. You need a logistics channel that genuinely understands the industrial environment.
Makes sense, someone who gets the urgency.
Exactly. This type of supplier focuses strictly on industrial-grade inventory, stuff for oil and gas fields, utilities, big manufacturers, and that means they stock massive quantities of proven, reliable products, like the BESTOLIFE 2000 series.
So it's not just a distributor, it sounds more like a dedicated pipeline for these critical consumables.
That's a great way to describe it, a dedicated pipeline. And that dedication translates directly into several key advantages that reduce your risk of downtime. Well, first, there's the wholesale pricing. Cutting out those middleman markups definitely helps offset the initial premium cost of the better compound we just discussed.
Okay, cost savings.
Second, and maybe even more critical, is inventory depth and fulfillment speed. They maintain industrial-scale stock that's always ready to move, usually in bulk. The source mentions lightning-quick fulfillment and, quote, no pointless back orders ever.
No pointless back orders ever. That's a bold claim.
It is, but for a procurement manager facing a tight drilling schedule, knowing that those critical specialized compounds like the NM or the Arctic grade are instantly available and in bulk, that's arguably as valuable as the compound's performance itself.
Because it keeps the project on schedule, stops the waiting.
Exactly. No waiting on materials. Plus, dealing with materials this specific, questions must come up, right?
Yeah.
Compatibility, maybe application methods.
For sure. The source mentioned technical support.
Yeah, and that's essential. When you're dealing with complex chemistry, maybe trying to decide if the NM version is right for a specific sour service job, or if the Arctic grade will work okay with a particular pumping system on the rig, you need answers fast. And you need them to be accurate, not just fluff.
No guesswork allowed.
Absolutely not.
Okay.
So having access to experts who can quickly confirm specs, check compatibility, that eliminates guesswork and helps prevent really expensive mistakes out in the field.
Okay, so let's try and synthesize all this. When a smart procurement manager makes that strategic choice, they decide to consolidate their needs around reliable, specialized products like BESTOLIFE 2000. And they source them through a specialized channel that offers that wholesale pricing and that supply resilience. What's the bottom line gain for them?
For the company.
The ultimate gain, I think, is predictability. That's the gold standard in any industrial operation, right?
Absolutely. Predictability is huge. They gain reduced downtime. Projects that actually stay on schedule. They preemptively eliminate those unexpected headaches from OSHA or the EPA thanks to using non-hazardous formulations.
Fewer surprises.
Fewer surprises. And then on the administrative side, the back end, they get simpler invoicing. Single invoice simplicity for all their bulk specialized chemical needs. It transforms what used to be, frankly, a complex and high-risk sourcing challenge into a much leaner, more predictable process that's fundamentally built around protecting the asset.
It really does tie the whole thing together, doesn't it? We started talking about, a single seized pipe joint, and we ended up analyzing how modern chemistry and strategic logistics have to work hand in hand.
They're inseparable for success today.
Yeah. It seems like switching from that older heavy metal tech to something like the BESTOLIFE 2000 series, it tackles both things at once. The immediate, potentially multi-million-dollar risk of a connection failure and those longer-term business risks around environmental liability. It's about getting cleaner, safer, and stronger connections across the board.
And that, right there, is the definition of securing a real operational edge.
Which leads to, I think, a final provocative thought for you to consider.
Okay, leave us with something to think about. If the ultimate goal is consistent performance and bulletproof regulatory compliance, this whole deep dive should prompt you to ask one more critical question. If something as fundamental as basic as your thread compound, the stuff protecting literally every connection in your infrastructure, if that was potentially based on outdated chemistry and just old habits, then what other critical supplies or maybe even processes within your operations might still be overlooked right now? Where else might you still be gambling on yesterday's technology to solve today's extreme high-cost problems? That knowledge really compels you to look around and evaluate.